Hello everyone! In this video, I want to show you how I made this Cyberpunk jacket. And this started out as a plain black faux leather jacket, and I added a bunch of programmable LEDs to the shoulders and to the back. All of the wiring is hidden inside the lining of the jacket, and in one of the pockets, I have a battery pack and a controller. Now the controller allows me to select between different lighting animations and different colors for the lights. But what really makes these lights look great are these hexagonal diffuser panels that I made using my 3D printer. To make these panels, I used the technique of 3D printing directly onto mesh fabric. And the basic concept is that you 3D print one layer of your design, pause the print, insert the mesh fabric, and then resume the print. And that sandwiches the fabric between the first two layers of your print. And when you have a sort of cellular design like these hexagons, you end up with a flexible 3D print like this. Now this is a technique that was pioneered by folks like David Shorey and Billie Ruben, and I will link to their work in the description of this video. You should definitely check out the amazing work that they do. Now there are already a bunch of tutorials out there showing you how to 3D print on fabric, but I'll walk you through the process that works for me, and then I'll show you how I used it to make this Cyberpunk LED jacket. Now, before I go into the process that I use, I feel that I should say that this is absolutely an experimental technique, and I do not recommend trying this until you're very comfortable with 3D printing and your particular 3D printer. You need to know how to pause a print, how to resume a print after it's paused, and how to stop a print completely should something go wrong. These are not prints that I leave going overnight. I don't leave the house while these are printing. I stick around and monitor them really closely so I can stop them if anything goes wrong. So yeah, just be careful. Okay, let's talk about how to make these things. The number one question I get about this process is what kind of fabric are you printing on? This is nylon mesh. It's also called tulle or net. It's essentially the material that ballet tutus and modern petticoats are made out of. You can buy it at most fabric stores and craft stores. It comes on bolts and you can buy yardage like regular fabric, but for 3D printing, I like to buy smaller widths on spools like this. The fabric rolls off the spool with no folds, and a 9 or 10 inch width is perfect for the size of my 3D printer. If you buy yardage, you will need to cut it down to fit on your printer and iron it on a low setting so that it's perfectly flat. The mesh I use is thin, 0.3 millimeters or less. Nylon mesh comes in different weights and sizes of holes. Tulle is generally very soft and net is stiffer with larger holes. You may need to test a few different types of mesh to find one that works well for your design. Keep in mind that you are limited by the size of your printer bed. Remember to leave some room around the edges of your design and around the edges of your fabric. You'll need the room to tape the fabric to the bed. .3D printing on fabric is really great for flexible designs, and you want to think about flexibility when designing your piece. The printed shapes will be rigid, and the open spaces will be soft, flexible fabric. You can experiment with different amounts of open space between your shapes until you get the drape that you want in the printed piece. I began by making a template from my jacket and scanning it into Illustrator so I knew exactly the space I was designing for. Then I created a pattern of hexagons that fit well within the space. Next, I exported the pattern as an SVG and imported it into Fusion 360. In Fusion, I extruded the hexagons with a taper, which made them look kind of like gems or studs, perfect for a leather jacket. When everything looked good, I exported my design as an STL. For slicing, I use Cura. If you use a different slicer, you'll need to figure out how to add a pause into your print after the first layer. This is how I do it in Cura. I load my model into the workspace on the center of the build plate. Then I open the Extensions menu and select Post-Processing and Modify G-Code. This will open the post-processing plugin, and this is where you can set up helpful scripts to be added to your G-code. I click on Add a Script and pause at height, and you can see that the script has been added in the left pane and the settings for the script are shown on the right. First, I changed the pause at from height to layer number. Then I set the pause layer to 1. This will tell the printer to pause after the first layer is completed. I leave disarm timeout at 0 and I set the Park print head coordinates to 0, 300. This will move the printer head out of the way and make it easier to put the fabric in place. I leave the retraction and extrude settings at default and I skip down to standby temperature. This is important. I set the standby temperature to be the same as my extruder temperature. So I usually print PLA at 205, so I set standby temperature to 205. This means the extruder stays hot while it's paused, so when you resume the print, it can start right away on the next layer. And that's it for the script settings. If you close the window, you'll now see a red number on the post-processing icon showing the number of scripts you have active. The script will be active until you manually turn it off, so anything you slice in Cura will pause after the first layer until you go back into the post-processing plugin and remove the script by clicking the X next to it. Once I have my script set up, I slice the model with standard settings at a layer height of 0.2 millimeters. For the thin mesh fabric I'm printing on, I don't make any other changes. Once my design is sliced, I'm ready to print it, but there's a little prep to do first because I want to make sure my fabric insertion pause is as quick and smooth as possible. So before I start the print, I measure and cut the mesh fabric, making sure it will fit on the printer bed with some room around the sides for tape. If your fabric has any folds in it, iron it on a cool setting to make sure it's perfectly flat. Then I set the fabric and a roll of blue painter's tape nearby, ready to go. I start the print and wait for the first layer to finish. I just hang out by my printer and wait for it to pause. When the printer pauses and moves the hot end off to the side, I place the mesh fabric onto the printer bed and tape down all 4 edges of the fabric. I'm moving carefully here to make sure that I don't bump the gantry or move the bed with my hands. I'm also being very careful not to touch anything hot. Remember, the hot end is still on and the bed is heated up as well. When the fabric is in place, I check the nozzle before resuming the print and remove any ooze that has appeared during the pause. Then I resume the print and watch to make sure the next layer goes down smoothly. Always be prepared to stop your print if there are any snags, and watch to make sure your fabric stays taped down during the whole print. You don't want it to peel up off the bed and become a hazard. If the first layer goes down smoothly over the fabric, I know I'm in pretty good shape because the fabric is now sandwiched in there. I still monitor the print and check it often to make sure everything stays adhered to the bed. When the print is complete, I wait until the bed is completely cool before I try to remove it. The print release is much easier from a cool bed. Be careful when removing the printed fabric, it's a bit delicate and can tear, so take your time. And that's how I 3D print on fabric to create panels like these. I've been doing a lot of experiments with different designs and different shapes to create interesting draping properties, and I'm also working on a full garment made using this technique. You may have seen this dress lurking in the back of my videos lately. I will be doing an upcoming video on this dress project, so make sure to subscribe and click the bell to be notified when it goes up. So here is a finished jacket panel. For my original tutorial about this project, I only did the back panels, but a little while later I realized I wanted some more light that could be seen from the front of the jacket, so I added the 2 panels that go over the shoulders, and that was pretty easy to do. If you look inside the jacket, you'll see the lighting circuit is completely hidden behind the lining, which protects the circuit and makes it easy and comfortable to wear. For step-by-step instructions for how to do this clean install, check out the tutorial for this project, which is in my Wearable Tech Projects book, and I'll link that down below. Now I'm going to open up the lining so we can take a peek inside. Here I opened up the center seam in the lining so I can show you the inner guts of the jacket, and this is exactly how I opened it up to put the electronics in. You can see I was pretty generous with my wire lengths between the lights, so nothing is pulling or under any strain while I'm wearing it. And I wasn't worried about it looking messy because I knew it would all be hidden behind the lining. I cut holes in the back of the jacket for the LEDs to shine through, then I built the strand of the LEDs and glued the lights into place. The lights are all daisy-chained together, and the beginning of the chain is connected to a Circuit Playground Express controller board and a battery holder in my pocket. I won't go too deep into the programming here, but it's pretty easy to program the Circuit Playground Express with MakeCode or CircuitPython or even Arduino if you're already comfortable with that. I have it programmed with 10 different settings that I can cycle through by pressing either of the 2 buttons on the board. Each setting also lights up a different LED on the board so I can see what color or animation my jacket is showing while I'm wearing it. For the original tutorial, I kept it pretty simple, but you can add as much complexity as you like to this. More complex animations, interactions with light, sound, temperature reactions. There are lots of ways to add more functionality to this. Well, that's it for this video. If you found this interesting or helpful, please like and subscribe. It really helps me out. Also, if you have any questions, drop them in the comments below or find me on Instagram or Twitter. And if you make anything from any of my videos or tutorials, definitely tag me so I can see it and share it. Thanks so much for watching, and I'll see you again soon.